I am Luyang from Nanjing Technology, from Nanjing University, and my presentation today is about the rapid modeling of the SLM formed blocks with the modified inherent strain method for the residual stress prediction. My representation consists of 5 parts. As we know, the thermomechanical coupling method is widely used to numerically simulate the AM process, and the accuracy of this method has been experimentally validated. And but this method requires expensive computational resource, and there are various methods has been proposed to improve the computational efficiency, such as the adaptive mesh technique and the Horner heating method and so on. But in essence, all this method sorry, this methods are scale up some TM method. So the required computational resource is still considerable. And so there are some researchers introduce the inherent strain method to the simulation of the AM process. But this method is originally proposed for the welding process. So different from the welding process, the AM process has an interplay effect. So when we applied the original inherent strain method to the AM process, then we cannot get a satisfactory result. So there are some researchers proposed to modify the inherent strain method, and this study is aimed to rapid model and predict the residual stress of the large size component, and to predict the with the MIS theory. So for the welding process, for the welding problem, the original inherent theory defines the inherent strain. The only source of the inherent strain is the residual plastic strain of the in the weld part after cooling down. But for AM process, there are the constraint due to the constraint between the layers. There are some part of the thermal strain converted to residual elastic deformation, and the modified inherent strain theory thinks that this part of the thermal part this part of the thermal thermal strain should be included in the inherent strain. So if we want to when we want to obtain the so-called inherent strains, we should develop the 3D detailed model, and with the thermal mechanical method. And this is the model we developed, and this is the blocks, and this is the substrate, and the detail of the model is listed here. And the inherent strain is extracted from the point at the center of the blocks. And this figure shows the elastic and the plastic strain at the center point. So and we can obtain the inherent strain of this point following the equation mentioned above. And we can apply this inherent strain into the model developed with the MIS method. this figure compared to the results obtained from the MIS method and the TM method. So we can see that the residual stress obtained from the MIS method distribute more smoothly than that obtained from the TM method, and the value is relatively lower because the MIS method applied the inherent strain into the entire layer at the same time and uniformly. So we also developed a model with large size use the MIS method, and this is a model, and the details of the model is listed here. This is the residual stress obtained by the MIS method, and we can see that in this pictures that the sigma x and the sigma y, and the sigma x and the sigma y distributed in the part with the almost the similar pattern, and the sigma zz distributed quite different from the sigma x and the sigma y. To verify the accuracy of the prediction, we an actual block with the same size has been created and with the same parameters. The residual stress on the top surface and the two lateral surfaces are measured with the XRD technique, and there are five measure points on each surface, and this picture shows the experiment, the results of prediction and the result of measurement on the top surface, and we can see that the error between the between the results are mostly less than 20%, and there are exacting point on the side on the left is more than 60%. This figure shows the compares the different results obtained by the MIS method and the XRD measurement, and we can see that on the lateral surface the error is almost less than 35%, and there are 2 points. 2 points the error is more than 60%, and one point is more than 40%. And the conclusion is that the whole the time cost of the whole calculation is about 30 minutes. So we can say that it is acceptable for the the modified inherent strain can be applied to quick rapid modeling and predicting the residual stress of the large size component formed by AM technique, and with acceptable accuracy. Thank you.